Hi, my name's Alan Taylor. I'm a retired management accountant with 40 years experience working with spreadsheets. This is a back to basics look at lowest common multiples and highest common factors. By way of a bit of background, a relative asked me to help his daughter with her GCSE Foundation Maths revision. I started to prepare revision material in Excel, and I used questions with model answers taken from the examiner's website. When I got to the lowest common multiple questions, I was baffled by the use of Venn diagrams. I passed my O-levels way back in 1971, and I can't remember ever being taught to find lowest common multiples using prime number factorization and Venn diagrams. It might be my memory letting me down, but the methodology seems contrived, and I decided to go back to basics. So the basics, what are they? Well, they're factors and multiples. And what are factors and multiples? They're the simple building blocks of multiplication. So if we take a factor of 2 and multiply it by another factor of 2, we end up with a multiple of 4. So what are common factors? Well, to demonstrate this, I'm going to use two sets of times tables, and to keep it really simple, I'm going to use the 2s and 3s. Every multiple in a 2 times table is a common factor of 2, i.e. every multiple from 4 through to 24 shares a common factor of 2. Likewise, every multiple from 6 through to 36 in the 3 times table shares a common factor of 3. So what are highest common factors? Well, highest common factors only come into play when we're looking at relationships across more than one set of times tables. So if we sit our 2s and 3s next to each other and start at the bottom, we can see that 4 and 6 share a highest common factor of 2. 6 and 9, a highest common factor of 3. 8 and 12, a highest common factor of 4. In fact, this entire column contains highest common factors for the pairs of numbers from its respective times table. So 12 is the highest common factor for 24 and 36. So what are common multiples? Well, every multiple in a times table is common to its 2 factors. It just is. 12 and 2 are common factors of the multiple 24. That's as complicated as it gets. So what are lowest common multiples? Well, as with our highest common factors only coming into play when there were more than one times table, the same applies to lowest common multiples. If we look at our 2 and 3 times tables, we will notice that they have common multiples of 6, 12, 18, and 24. But not only are they common, they're the lowest common multiple. Why? Well, because they are. If you look at the number 6, it is the lowest common multiple for factors 3 and 2. If you look at multiple 12, it is the lowest common multiple for factors 6 and 4. 18 is the lowest common multiple for factors 9 and 6, and 24 is the lowest common multiple for factors 12 and 8. And if we sit these groups of numbers next to each other, you'll notice that we've now got the first 4 multiples of the 2, 3, and 6 times tables, i.e. 2, 4, 6, 8, the first 4 multiples of the 2 times tables, 3, 6, 9, 12, the first 4 multiples of the 3 times tables, and 6, 12, 18, and 24, the first 4 multiples of the 6 times tables. And we already know that when we have numbers in the same position from different times tables, that their factors are in fact highest common factors. So 12 and 18 and 12, 8 and 24 share a highest common factor of 4. 9, 6, 18 share a highest common factor of 3. 6, 4, and 12 share a highest common factor of 2. 3, 2, and 6 share a highest common factor of 1, but I'm not going to put the number 1 there. I'm going to use the word base. And the reason I did that will become apparent as we carry on through the video. Now we have these numbers of tables, let's do the obvious and put them into a table. So, and this is what they look like with our highest common factors in column 1 on the left-hand side, our lowest common multiples in column 4 on the right-hand side, and our 2 times tables wedged in the middle. So if we label our times tables A and B, we now have a simple Excel table in which we can start to plug formulas. Right, starting with HCF. The HCF simply tells us how high up in the table the pairs of numbers sit. So the number 4 is telling us that 8, that is the position that 8 and 12 sit in this table compared to the base 2 and 3. And to find that position, all we have to do is say it's equal to A divided by its base, which is 4, 8 divided by 2 is 4, or equal to B divided by its base, which is 12 divided by 3, which is 4. If we look back at our 2 and 3 times tables, we know that 8 times 3 equals 24 and 12 times 2 equals 24. So this gives us two simple formulas for finding our lowest common multiple. And what we're actually doing is multiplying our numbers by our base numbers. So if we go into our LCM and we put in the formula equal to A, 8, times base B, 3, that's our 8 times 3, which is 24. We can also put in there equal to B times base A, 12 times 2 equals 24. Some other numerical relationships, we can see at a glance that LCM 24 is equal to HCF times base LCM. So we can put that formula in equal to HCF times base LCM. 4 6s are 24. We know that 6 is a multiple of the factors 2 and 3, so we can replace base LCM by its factors, base A and base E. We have another, which gives another formula for lowest common multiple, which equals HCF times base A times base B, 4 times 2 times 3, which equals 24. If we look at a single row, we can see that 4 times 6, 24 equals 2 times 12, 24. In other words, HCF times LCM equals A times B. Not a very useful formula, but it does provide us with two new formulas for lowest common multiple and highest common factor. It tells us that lowest common multiple equals A times B divided by HCF. So equals A times B divided by HCF. Gives us our answer 12, and HCF equals A times B divided by LCM. Gives us our answer of 2. And this bottom one, HCF equals A times B divided by LCM, you will see me using later when we're working in Excel. Right, moving on. Let's say we've been given the exam question, find the lowest common multiple and highest common factor for the numbers 84 and 140. We start by finding our base values of 84, 140. We can see that 2 is a common factor. We divide by 2, leaving us with 42 and 70. They can be divided by 2, leaving us with 21 and 35, which are both divisible by 7, leaving us 3 and 5. We know that 3 and 5 have no common factors. That gives us our base numbers. Now we can use one of our LCM formulas, A times base B, 84 times 5, which gives us our LCM of 420. We could have also said 140 times 3 equals 420. The easiest way to find our highest common factor is to multiply the factors. So all we have to do is say 2 times 2 is 4, 4 times 7 is 28. We could have gone longhand and said equal 140 divided by 5 equals 28, or 84 divided by 3 equals 28. Right, so that's given us a partially completed table. So by way of practice, let's carry on and complete this table. We'll start by finishing off our HCF column. We know that this one is equal to 21 divided by 3, giving us 7. We know that this one equals 42 divided by 3, which gives us 14. Now our LCL column, the lowest common multiple for 3 and 5 is 3 times 5. So that's equal to 3 times 5, 15. Our next one is equal to A times base B, which is 105. And the one after that can be equal to B times base A, which is 210. And there we have it. With very little effort, we've found the highest common factors and lowest common multiples for 3 pairs of numbers: 21, 35, 42, 70, 84, 140, and in a format that definitely works in Excel. In fact, this relationship is so basic that in Excel, you don't even have to enter any formula. Simply enter the bottom 2 rows and drag them up. I've already done that. I've entered the bottom row 1, 3, 5, 15, doubled it to 2, 6, 10, 30. If we cover those, drag them up, we replicate the table I've already generated over here on the right-hand side, and highlighted are the numbers we generated in the previous little table, with 21 and 35 sitting in position 7, 42 and 7 in position 14, and 84, 140 in position 28. And we can see here now that in 28, our highest common factor is just telling us how high up the table the 3, 5, and 15 times tables or pairs of numbers sit, and that our lowest common multiple is just HCF times our base lowest common multiple, 28 times 15, 420. Fairly straightforward. Obviously, we wouldn't use that technique to solve a problem. I was simply demonstrating how basic the relationships are and how easily Excel can replicate them. If we wanted to find the HCF and LCM for numbers 84 and 140 using Excel, entering the formula LCM 84, 140 would give us our answer of 420. But HCF requires slightly more effort because Excel doesn't have, or I certainly haven't found it, a highest common factor function. But if we use our single row formula from earlier, we know that highest common factor equals A times B divided by LCM. So therefore, entering 84 times 140 divided by LCM 84, 140 should give us our answer of 28. Let's give it a go. Equal 84 times 140 divided by LCM 84, 140, close bracket, cross fingers, and it gives us an answer of 28. Right, moving on. What are the 3 numbers? Well, start by finding the lowest common multiple for the 2 highest numbers, 2 and 3. Then use that LCM with the lowest number to find the lowest common multiple for all 3 numbers. Note that if 1 is a factor of either 2 or 3, you don't need to bother with this second step. Example, find the highest common factor and lowest common multiple for the 3 numbers 28, 42, and 70. Start by finding the lowest common multiple for our 2 highest numbers 42 and 70. 2 is a common factor, leaving 21, 35. 7 is a common factor, leaving 3 and 5, which there are no common factors. So we can multiply 70 by 3 to give us our lowest common multiple of 210. We can then pair that up with the lowest common multiple, 28, and repeat the process. 28, 210 divided by 2 is 14, 105. Both divisible by 7 leaves us 235. No common factors, multiply 210 by 2, and we're left with 420 as the LCM for 28, 42, and 70. Highest common factor, simply 2 times 7 equals 14. So what are the 4 numbers? Well, put them in pairs, 1, 2, 3, 4. Find the LCM for each pair, and then the next level down will give you the LCM for 1, 2, 3, and 4, and so on. For 5, pair off 2, 3, 4, and 5, then tag on 1, always working backwards from high to low. Well, that's it. Hopefully, by remaining focused on times tables, you now know everything you will ever need to know about lowest common multiples and highest common factors, and not a factorized prime number or overlapping circle in sight. I hope you found this useful.